Hi guys, so what we're going to do today for lesson 5 is we're going to basically do what I showed you guys in class yesterday on Zoom, which is we're going to find where a parabola and a line intersect, which we did graphically. We did this on a graph in lesson 3. We're going to find these points of intersection, which are represented by coordinates x comma y. We're going to find that algebraically without graphing. So we're going to be given a system. You might see braces around the system like this. One of them represents a parabola. The one with the squared, x squared, is the quadratic. That's the parabola, or quadratic. And the one with just y and x, that's your line. That's linear. That's y equals mx plus b. So in order to find where they intersect, we're going to use substitution. And if you remember substitution, you isolate one variable and substitute for that variable in the other equation. So in this example, I have y already isolated here. So everywhere I see x squared minus 4x plus 4, I can replace y with that expression. So in the second equation, I see a y. So instead of y, I'm going to put x squared minus 4x plus 4. So I'm going to write 2 times, and again, I'm replacing y with x squared minus 4x plus 4. And then I keep copying the rest of the equation equals x plus 4. I have substituted y. In these problems, it's always easier to isolate y and substitute it, not to isolate x, because then x gets squared and that can get annoying and complicated. So we're just going to, what we're saying now is we're saying where do the two equations equal each other? Where do these two equations equal each other is really saying where are these points of intersection? Okay, so we're going to solve this quadratic. We're going to distribute. I have 2x squared minus 8x plus 8 equals x plus 4. I'm going to, since I notice I have a quadratic, I'm going to set it equal to 0. So I'm going to subtract x and I'll subtract 4. That's going to give me 2x squared minus 9x plus 4 equal to 0. I'm now going to factor. I look for a GCF. I don't have a GCF to pull out, so I'm going to factor into two binomials. This is going to be 2x times x is 2x squared. This here, a being greater than 1, tells me that I'm going to have to use guess and check, that the factoring is going to be one of those annoying ones. So I'll try factors of 4. I'll try 1 and 4, or 2 and 2, and I have to try switching. So if I try like 1 and 4 here, and I try outsides and insides. Outsides give me 8x, insides give me 1x, and that works to be 9x. So that actually worked out on the first try. And I need a negative 9x, so that means both of these are negative, which made sense because the signs are the same. So minus minus equal to 0. So I have 2x minus 1 times x minus 4 is equal to 0. I'm going to set each of these equal to 0, so I now have give myself some room. I now have either 2x minus 1 is equal to 0 or x minus 4 is equal to 0. And I solve each one separately. Here I add 1. I get 2x equals 1. Divide by 2. X equals 1/2. And here I add 4. X equals 4. Now, normally when we solve a quadratic, we're finding its roots, and we usually stop at the x values. But here, remember what we're doing, we're finding the point of intersection. We're finding these coordinates here. So we want to know where these two equations equal each other. So we also need to find y coordinates. So right now what we have is 2x coordinates. So we basically have like 1/2 comma something for the first point of intersection, and then we have 4 comma something for the second point of intersection, and we have to find out the y coordinates. So you do that by taking these x coordinates and plugging them in to either of the two equations. So if you plug in, I can't scroll this page. Okay, if you plug into the first equation, I'm just going to move this down. If you plug into the first equation or the second equation, they're both going to give you the same answer. So obviously the second equation is easier. 2y equals x plus 4. I'm having trouble with this thing here. Okay, so 2y equals x plus 4 is what I'm going to plug into. So 2y equals x plus 4. I'm going to plug in 1/2 for x. So 2y equals 1/2 plus 4. That's really 4.5. So 2y equals 4.5. And then you could divide both sides by 2. Y equals, I know you guys don't like to do this by hand, but this is 9 over 2 divided by 2, which is really 9 over 2 times 1/2. So without a calculator, this is going to be 9 over 4. Okay? And then if you plug a 4 in to 2y equals x plus 4, 2y equals 4 plus 4, 2y equals 8 divided by 2, y equals 4. And that's your second point of intersection. So you have 2 points of intersection for the parabola and the line. And if you had graphed it, you would have come up with exactly the same 2 results. Okay, so your examples for homework are, I think, 3 or 4 of these, all very similar. Use substitution, follow the notes. Okay, thanks, bye.